Get your notes out. We're going to talk about chords today. Not a big deal. One extra little thing you need to know about circles. First of all, I want to define what a chord is. A chord is a segment with endpoints on the circle. So if you have a circle, and you put a point over here, and you put a point over here, points A and B, they're on the circle. You connect them. It's called a chord. So we call this chord AB. Now a chord is a segment, and segments usually are labeled with a little bar right on top of it. So technically I should label this like that, but oftentimes you will have a problem where it will just say, find chord AB, but it won't have the bar on top of it. But you need to know that because it says chord, you are talking about a line segment. You're not talking about the arc. You are talking about the segment, the straight line that connects the 2 points. This picture happens to also have an arc AB. So do you see the difference between the way the two of them look? AB has an arc symbol on top. Chord AB has a little line segment symbol on the top of it. You okay with that?
Yes.
Now, what are you going to have to use this for? How are you going to see them? Can I flip pages? Okay. Draw yourself another circle. Put a point in the middle. One more thing I want to tell you. What if I did this? What if this was point P, this was point A, this was point B, and I connected them like this? Is that a chord?
Yeah.
Is it a chord? Why is it a chord?
Because it goes straight and
It has segments on the circle. It doesn't say anything about it not being able to go to the center of the circle. It can go to the center of the circle. So more specifically, this is a chord, but what else do we call this? We call it a diameter, yeah. Okay, so this is a chord AB. Do you need the third letter?
No.
No, you don't need the third letter. So in this case, you would still call this chord AB. So in other words, you always label a chord based on their beginning point and their end point, not the points in the middle, okay? Angel.
What letter is that in the middle?
A P. I want to make the first picture too confusing. So draw a point at the center, call it P. Draw in a chord. We'll call the chord, let's call it M and N this time. We have chord M, N. I just want you guys to notice that if I connect the endpoints of that chord to the center of the circle, what shape have I created?
Triangle.
A triangle. Now the problem is nowhere in here do I know that I have a 90-degree angle. So you are going to use SOHCAHTOA when you do these again. But what you're going to be doing is connecting the center of the circle to the middle of chord MN. What do you think is created when you connect point P to the middle of chord MN? Two right angles. We have two right angles here. I'm going to call this point C. So first of all, we got to write some stuff down about this. So PC is the perpendicular. What does that mean? Sorry. Squeeze it in there. It forms right angles, yes. PC is perpendicular to chord MN. To chord MN. It also I'm going to ask you things today. I'm going to ask you, well, what is the perpendicular distance between the center P and chord such and such? And there'll be a chord drawn in your picture, and you have to figure out what is this distance right here. So I'm going to give you a couple of examples, and then I'm going to let you guys try some of these yourself. So go ahead, draw yourself a circle, put the point in the middle. I'm going to draw chord AB, point P again. Here's A, here's point B. I'm going to connect them like this. Drawing your triangle. And I'm going to tell you in this picture that the radius of this thing is 4. And I'm also going to tell you that the measure of angle APB is equal to 100 degrees. The measure of angle APB is 100 degrees. So as soon as you see situations like this, you guys, you're going to be creating the same picture a lot, just like you have been in the last problems that you were doing. The radius is 4. So go to your picture, and where you see a radius, draw in 4. Now, this is what happened last hour. There was the very first picture on your assignment has a point on the outside of the circle over here called something else. Let's call it point C. And people saw that point C and immediately thought, oh, I need to draw in another radius here. Don't draw in another radius. Draw them in only where you need them. And you need to create a triangle right here. So don't draw in radiuses, radii, where you don't need them, okay? So here we have a radius of 4. So that's 4, that's 4. The measure of angle APB is 100. So this whole angle right here, 100 degrees. But if I am asking you to find what is the perpendicular distance between point P and chord AB, you're going to need to draw this in. So let's put it out here. Find perpendicular distance between P and AB. Segment AB. That means to you we're talking about chord AB. So if I'm asking you to find the perpendicular distance between this point and that chord, I have to draw it in first of all, which I already have, but I also created some right angles here. Whenever you draw in that perpendicular distance, you create right angles, and then you're going to work with this triangle right here. Notice when I drew that segment in, it cut that 100 degree angle into what? 250 degree angles. So we're really working here with a 50 degree angle. All right, so what I'm going to do here is take this triangle, and I'm going to redraw it over here. Here's a 90 degree angle. This side over here is 4. What is that, you guys? What is 4 called? In this triangle, 4 is the hypotenuse. Yeah. This angle right here, that is the 50 degree angle. Your job is to find the perpendicular distance. You want this segment in the triangle, which is this side over here, which we're going to call x. So for TOA again, you're going to use sine, you're going to use cosine, you're going to use tangent. What are you going to use?
Cosine.
Now in this case, we have the adjacent side, we have the hypotenuse. Adjacent and hypotenuse is cosine. So we have the cosine of a 50 degree angle is equal to adjacent x divided by the hypotenuse, which is 4. Do we multiply or divide? Self-correct, multiply. So we're going to take 4 times the cosine of 50 degrees. 4 times the cosine of 50 degrees, what do you get?
2.86.
2.6.
6.
2.6. So that's the perpendicular distance between point P and chord AB. What about this? I'm going to backtrack a little bit here. What about this? What is the measure of arc AB? What is the measure of arc AB?
100 degrees.
How do you know it's 100 degrees?
Because it's the same as inside angle.
It says inside angle called central angle. Cool. Arc AB, this arc right here, is the same as its central angle. So if we know that that's 100 degrees, we know that arc AB is also equal to 100 degrees. What if I asked you for the measure of arc ACB?
It's 160.
Yeah, you're going to take the whole circle, 360 degrees minus the little part that you know. So 360 minus 100 is 260 degrees. 360 minus 100. All right, what about one more question? What if I asked you for the length of chord AB? How long is chord AB? In other words, I want this whole length right here.
Wouldn't it be
I'm going to call this Y now. I'm only going to call it Y because I've already used an X. So if I found that little part right here, what do I do to it to get the whole length AB? Just double it. Yeah. I'm supposed to do that quickly, then I'm going to stop. This is a 50-degree angle. That's opposite. The 4 is the hypotenuse. So again, I'm going to draw my triangle up here. I have a 50-degree angle. I know that that is 4, and I'm trying to find that side, which I just called Y.
so what
Sine, cosine, or tangent?
Sine.
Sine. Good. This is opposite. That's the hypotenuse. So we have the sine of 50 degrees is equal to Y over 4. So Y is equal to 4 times the sine of 50. Help me out. What do you get?
20. Oops, forgot something.
3.1.
3.1?
Yeah.
All right, so that is, this distance is 3.1. What do I need to do to it?
Double it.
You need to make sure that you multiply it by 2. This ended up being a little messier than I had intended it being. So it ends up being equal to 6.2. Chord AB has a total length. This whole length right here is going to be equal to 6.2. Those are the kinds of things that you're going to have to do today. It will ask you to find angle measures too. What is the measure of angle, blah, blah, blah? Well, what do you do when you find the angle measure? What's the extra button you had to press on your calculator? Second. Second sine, cosine, or tangent. All right.